So I'd just like to thank Julian and yourself, for having me here today. So as I was asking, what should I be talking about? SARS-CoV2, so I was quite lost. And Julian said, okay, just share my previous experience. So this is just a little bit of an introduction about how I entered into coronavirus during the 2003 SARS episode in Singapore. So at that time, it was pretty much quite unknown. And in Singapore, you could see that it was actually the SARS-CoV-2, the SARS-CoV experience in 2003 that sort of started the whole landscape in strengthening the infectious diseases aspects in Singapore. So you could see this shows what has been happening. And of course, I spent quite a bit of time starting my research group in chikungunya, and I'm still working on that. But like I think everyone else, we are all pulled back into SARS-CoV-2 somehow. So back in Singapore in 2003, this was what it looked like. And if you look at it right now, it didn't look quite different, it's so many years after. But I have to say that back in 2003, obviously the infrastructure was a lot less. And also in terms of the research tools were also a lot more limited. But nonetheless, at that time, I was a young postdoc at the Genome Institute of Singapore. So with my prior knowledge in coronavirus, my PhD was actually on IBV. So it's really nice to actually listen to all the talks today. And so with that knowledge, I was part of the larger genomic sequencing team that went on to complete the sequences of the SARS coronavirus. And with that information, it also determined the routes of transmission, that actually trace how the first index case in Singapore was actually infected, which was obviously on a shopping trip to Hong Kong over a long weekend. But with that knowledge, I was then put into the team on the molecular diagnostics task force. And I was one of the lead researchers at that time to develop the Roche SARS-CoV-2 detection kit. So this was really precious, in the good old days where the light cycler was the machine of the century. So with that knowledge, it really sort of brought some kind of awareness to myself as a researcher that, whatever we have established as in your PhD, it will actually be very useful in if you are able to apply it differently. I think I was just taking off from Paul's comment, for the younger researchers out there. So you never know how your career will actually evolve if you actually keep an open mind. But so fortunately at that time, I think SARS was around for not more than 6 months. And by June, we were off the list and it sort of went away. So when the wake-up call again started last year in January 2020, of course, there was a lot of excitement and also fear. But I guess the whole world actually thought that it will be gone in a year's time. But unfortunately, I think we are still where we are. And so with all those changes that has taken place, so A*STAR itself as a government agency in Singapore was also transforming, and it sort of reorganized several of the research institutes. And as a result, a new research entity, the A*STAR ID Labs, was started with a very strong focus on epidemic preparedness. So just to introduce you a little bit about the focus of the ID Labs, it's really to be a leading center in ID research excellence in some of these areas, and how by understanding the pathogenesis of the various diseases would then allow us to pivot quickly to in the times of a need. So these are the three key pillars with a horizontal that will actually enable all the various discovery from diagnostics to understanding pathogenesis and even antimicrobial resistance to put this into an epidemic preparedness platform. So these are some of the social media for you to take a look. Now, I think I'll just spend the rest of my time very briefly to share with you based on the earlier experiences of the SARS, and then we had the various arboviruses outbreaks over the last 10 to 15 years. It actually pulled the community, the research community, and the clinical community in Singapore closer together, where there were different opportunities to initiate research projects. So as a result, one of these study group, which is called the PROTECT, you could see from here, it's a multi-center prospective study, which is led by the National Center for Infectious Diseases. And I just have to stress that this particular protocol was written a couple of months before SARS-CoV2. This was actually in preparation for the next disease X. So at A*STAR, we work very closely with the NCID because we are a partner in PROTECT, together with the National University Health System and also Duke NUS. And these are the various aspects that how we're going to come together, the whole of Singapore, and work to understand and tackle COVID-19. So from multiplex cytokine profiling to high-dimensional immune phenotyping, epitope mapping of the specific linear B-cell epitopes, also the development of various pseudovirus assays, and also the S-flow detection assays that could allow us to comprehensively characterize responses to COVID-19. So I'll just share a little bit, a few examples. So one of the most immediate thing that the teams started on was really to understand and identify specific immune signatures of COVID-19 patients. So you could see from here by classifying the patients into three categories, from no pneumonia to the mild and moderate disease phenotype, to the more severe ones, which most of these patients ended up in the ICU. And you could see very clearly that the pro-inflammatory signatures will then increase as the disease severity gets more severe. So clearly providing the essence of a cytokine storm. And we followed this group of patients, and this was actually a study that was completed early this year when for 6 months. And you could see from here that the same group of patients, of course, they have already sort of cleared most of the symptoms. And you could see that the inflammation markers also most were subsided by the 6 months post-infection. And we are actually completing the 18-month study at the moment, and it will be quite interesting to compare some of these in the next time I could share with you. But I'd just like to stress a little bit of observation that, despite the fact that, at that time, by the 6 months time point, all the patients have already recovered, but by doing a PCA analysis, you could still separate out the patients very clearly from the healthy, non-infected, and compared to those who actually were infected by SARS-CoV-2. So I think all this profile actually provides to be very useful for us at this point where Singapore, unfortunately, is still dealing with the surge in outbreaks despite the high percentage of vaccinated people. So I will just share a little bit with you that the profiles are actually very different. So another part of the work is
Lisa,
using,
sorry.
yeah.
Just to interrupt you, you're on 8.5 minutes now.
Yeah, I'm almost done. So by doing the deep immune phenotyping, it allows us to also identify the specific surface markers in the different immune subsets. And this is an example where by looking at by using a flow, we were able to actually show the increase in expression of CD169 and the CD11b high neutrophils in the acute patients. And when we analyze the heat map of all this, you could see from here that the neutrophils actually showed a significant upregulation, as you could see from here. But what is more interesting is that when we look specifically at this group of CD16 low, high, and CD10 negative subsets, which represents the immature neutrophils, you could see that it clearly significantly differentiates those infected patients during the acute state compared to the time when they have already recovered. And this then enable us to potentially use this as a good prognostic marker if you are to sort of a triage the patients. And when we compare this to another group of the asymptomatic patients, you could see from here that again, you can use this to differentiate very clearly the immature neutrophils, the cell number is a lot higher comparatively. And I'll just finish off with detection, one of the serology assays that was established by my colleague, Lohan Rainier, which is what we call the S-flow detection. It is a high throughput flow cytometry, which is aimed at detecting the IgGs against the spike. Now with that assay, it is still currently being used, not just to look at natural infection, but it's actually currently being used to in part of the entire Singapore vaccine monitoring efforts. And you could see from here that people who were vaccinated with both the mRNA vaccines and other non-mRNA vaccines also develop quite good levels of anti-S IgGs. And in terms of when we separated out the age, you could see that those older than 60 also actually respond quite well. So I'll just finish off that. So like I said, because of the previous experience of SARS, they actually brought the communities closer together, and how the whole of Singapore then worked together to contribute to both the scientific research and how some of these were used to facilitate clinical management of the patients and assays that were established that allow us to monitor the immune responses, and also obviously the current Delta variants outbreaks. And how could we then continue with some of this established workflow, not just both locally, but also with our overseas partners. Julian and team, they have been also involved in some of the studies, and just to give all the acknowledgement here. And again, I hope to get to meet some of you, see some of you again in 2022. Thank you for your attention.